Congruence and Coordinate Geometry. Today we're looking at lesson 711, which is titled Defining Congruence. Are the polygons congruent? That is the question for the day. All right, so starting with question 7.3, it says two polygons are congruent if one is the image of the other following a sequence of rigid transformations, either a reflection, a rotation, or a translation. That is, there is a sequence of rigid transformation that maps one polygon onto the other. Part A, directions say, which of the polygons below appear to be congruent? What sequence of rigid transformations demonstrates the congruence between the polygons? The figures are drawn to scale. All right, so what you're going to do is you're going to look among these polygons and you're going to see which of them is a rigid transformation of another one. Basically, they're going to be the same size and the same shape, but they're going to be moved somehow. For instance, E and H. So here's E, here's H. They are the same size and the same shape, but they are a reflection of each other. Okay, if you took E and you flipped it over, it would make H. Okay, there's also G and L. Here's G, here's L. G, if you take it and you rotate it, would make L, right? Then there's F and K. Here's F, here's K. Same thing, it's a rotation. If you turned it, F would map onto K, right? Try and figure out a few more. Write them down over here on the side. Part B says, for each pair of congruent polygons, what can you say about the corresponding angle measures and side lengths? Considering the definition of congruent polygons, why would this have to be true? So they're going to have equal corresponding angle measures and equal corresponding side lengths. So that we're basically defining what it means for something to be congruent versus being equal. Equal is reserved for numbers. For instance, 9 equals 9, right? But we use congruence when we're talking about polygons or angles or sides. So we'll say angle A is congruent to angle P, okay? We don't generally say that they're equal. We say that they're congruent, okay? But if we're talking about the measures of the two sides, this one's 3 inches and this one's 3 inches, you would say 3 inches equals 3 inches because that's numeric, okay? All right, question 7.4 says, in problem 7.3, you concluded that if two polygons are congruent, then the corresponding angle measures are equal and the corresponding side lengths are equals. Conversely, if two polygons have equal corresponding angle measures and equal corresponding side lengths, then the two polygons are congruent. And there is a sequence of rigid transformations that maps one polygon onto the other. So part A says, are the two triangles below congruent? Okay, so here's our two polygons. So you want to see, can you map all of the sides of the first triangle to all of the sides of the second triangle? So pick any side to start with. I usually start with the smallest one. We've got 16 right here. Is there a corresponding side length on the second triangle? Yes, right here, that also says 16. And it has a little slash up there, so I'm going to assume they want feet. So 16 feet and 16 feet. So we have one corresponding side. Triangles have 3, so we need to get 2 more corresponding sides. So this one over here says 63. This one's blank. So we need to figure out what that side might be. And then this one over here says 65. And this one over here is blank. So they may or may not be corresponding. This is a right triangle, so we can use something called the Pythagorean Theorem to figure out the length of this side over here. But first, let's figure out the angles. So who knows what this little box means? It means it's a right angle. How many degrees does a right angle have? 90. So you're going to write down that the little box is 90 degrees. So this one has this triangle, the first triangle has one, and the second triangle has one. So we have a 90 and we have a 90. Bless you. If you want to write 90 and you want to write 90, go for it, or just write down that the little box means 90. Okay? This angle is 75.75, and this angle is 14.25. At first, it appears that they are not congruent. But could this small one over here be the same as this one? And this bigger one over here be the same as this one? Let's find out. How many total degrees in a triangle? 180. Okay, they should add up to 180. We already have 90, which means there's 90 left. So we're going to take 90 minus 75.5. If you punch that in your calculator, guess what it equals? It equals 14.25, which means this angle right here is 14.25, which matches up with this one, which is 14.25. So if this one's 75.75, then this one has to be 75.75. So all three angles are congruent. Okay? Now let's use the Pythagorean Theorem to see if this third side is 65 feet. Okay? So we're going to take the two sides that we know. We know the 16, so we're going to square it. We know the 63, we're going to square it. We're going to see if it's equal to the hypotenuse squared. So you're going to take your calculator and you're going to multiply 16 times 16. You'll get 256. Then you're going to take your calculator and you're going to multiply 63 times 63. And you're going to get 3,969. Then you're going to take your calculator and add those two numbers together. 256 plus 3,969 is 4,225. And most of you probably don't have that one memorized, but it is a perfect square. If you take the square root of that number, you get 65, which means this side right here is 65 feet. So from the first triangle to the second triangle, it's going to match up with that third side, the hypotenuse. So now we have all three sides congruent. So if you want to answer this question, are the triangles below congruent? The answer is yes. They are congruent. All three sides are congruent. All three angles are congruent. Okay? If so, what is the sequence of rigid transformations? Reflection, rotation, or translation that maps the triangle on the left onto the triangle on the right. If the triangles are not congruent, explain why not. Well, we already explained that they are congruent, but to get from this triangle to this triangle, what transformation would you use? A rotation. You would use a rotation, and then I followed it by a translation. So I rotated it, and then moved it over, followed by a translation. Okay? All right. I'm going to move this up. You'll see it in just a second if you're still writing. All right. There it is. Okay, question number 7-5. It says to represent the fact that two polygons are congruent, you're going to use that congruent symbol. For example, if two triangles are congruent, and this can be stated as triangle ABC is congruent to triangle DEF. The order of the letters in the name in each triangle identifies which sides and which angles correspond. For example, the congruence statement, triangle ABC is congruent to triangle DEF, indicates that angle A corresponds to angle D. How do we know? They both come first. So, which angle would correspond to angle C? F. Angle C would be congruent to angle F. Which side would correspond to side BC? EF. Okay? Because that comes second and third, so you want to pick the one that's second and third. So it has to follow the same order. If you said that side AB was congruent to side EF, you would get it marked wrong. Has to be in the same order. All right. So we need to do part A. Part A says that Luis wanted to write a statement to convey that the two triangles below are congruent. He started with triangle MNP, but got stuck because the triangles were not oriented the same way. Okay? They were probably rotated, right? And so he got confused. Complete Luis's statement for him and explain how you determine your answer. Okay? So we're looking at triangle MNP. We're going to say that if this is the first one, this is the second one, this is the third one, we need to match it up to the corresponding sides of the second triangle. So between the first and the second sides, we need the 20 meters, which is right here. Then we need to make sure that the 1 is closest to the 8 millimeter side, which is going to make it U. That makes this angle 2, and this one the third one. So you have to say that triangle MNP is congruent to triangle UWV. If you said that it was congruent to triangle WVU, you would be wrong. It has to be the same order. Okay? All right, and part B says, what sequence of rigid transformations would map the triangle on the left onto the triangle on the right? So how do we get from the first triangle to the second triangle? Anybody know which of the 3 transformations it would be? Yes?
It would be reflection.
Yeah. And followed by a translation. So you would reflect it down, and then you would move it over. So I did a reflection, followed by a translation. And we have one more question. All right, part C says label the triangle's vertices below from question 7.4, and then write a congruent statement for the triangles. So I labeled them A, B, C, and I labeled them D, E, F. And then I wrote my congruent statement. Triangle ABC is congruent to triangle DEF. Mostly because they didn't tell me what to label them. All right. Finish copying that down.